You may think of mosquitoes as an annoyance, but in most parts of the world they can carry diseases. The Aedes aegypti mosquito carries the dengue virus. More than half the world's population is at risk. On this map, red areas show where outbreaks of dengue fever have occurred. Blue areas indicate regions that are also infested with the Aedes aegypti mosquito, but have not yet experienced outbreaks of the fever. Each year, over 50 million people are infected. Approximately 1 in every 1,000 cases is fatal. To fight the disease, scientists need to understand how the virus attacks at the cellular level. As the female mosquito pierces the skin, searching for blood, it injects saliva and with it, the dengue virus. 7 to 10 days later, the virus has made its way into the bloodstream, infecting more cells and reproducing in large numbers. Each time the dengue virus reproduces, it must release its RNA. Here, inside a human cell, the approaching blue sphere is an endosome. It's actually a piece of the cell membrane that enveloped the virus at the cell's surface and ferried it inside the cell. The cross-section of the endosome reveals the dengue virus, which is covered by a protective shell of proteins. The white plumes are protons being pumped into the endosome. This routine mechanism lowers pH, which in turn causes the viral proteins to change their arrangement, exposing the viral membrane. The proteins shift their shape to form trimers, each made of 3 proteins. The trimers' tips, called fusion loops, stab the endosomal membrane. Once the trimers are anchored in both the endosomal and viral membranes, the proteins fold back on themselves, pulling the 2 membranes together. First, the outer leaflets of each membrane fuse. Then, as the folding back continues, the inner leaflets fuse and an opening forms called a fusion pore. The virus's RNA is forced out through the fusion pore, spilling into the cytoplasm. These RNA strands will hijack the ribosomes of the host cell, which will begin to synthesize viral proteins, creating the building blocks for new viruses.